So I told you about the one-shot camera. So the monochrome camera with the red, green, and blue filters. Why image with the monochrome? Why image with the mono camera? Because you don't have a Bayer matrix. What the hell is a Bayer matrix? Some of you might know. I don't know if you don't. Basically, how a digital camera works is you have a sensor over your pixels, right? You have a million pixels underneath. Okay, they're literally like wells, and they collect your light, okay? So what happens is the photons are coming down, hits your sensor, which is a silicon sensor, and knocks off, a photon will knock off an electron, and that will be captured in your pixels underneath that sensor. So they're like wells. As the well fills up, your pixel goes white, okay? As the lower amount of electrons in that well, you black, okay? So that silicon sensor has no idea what colour those photons are, it just does not know. So essentially, that's a monochrome camera. How would you make it a colour camera? Well, you put in a Bayer matrix, which is a colour filter. So you have a matrix like this over your sensor. I think there are like millions of pixels in it. So you'll have red, green, blue, green. There's twice as many green to blue and red because your eyes are adapted or evolved for seeing green better. And it's something to do with that, don't ask me anymore. So where you have a green filter, it'll allow green through. Where you have a blue filter, it'll actually, reflect that green, it won't let it through. Again, red filter gone, or red photon gone. Another green filter here goes through, blue photon gone. So you can see you're losing a huge amount of data with your colour camera, okay, because you have that Bayer matrix on top of your sensor. So you're only allowing photons in where there's a filter for that colour, right? So, does that make sense? Yeah? Okay. So, what do you do with your monochrome camera? Bit more work to it. I can't speak enough of one-shot colour cameras. I have one myself. The process is much easier. You go out, you take pictures, you stamp them, you cross them, done. With your monochrome, you do that 4 times. So you have a red filter, and you image through that for a couple of hours, right? So it allows all your red photons in. Then you swap over and you do your green, it allows all your green in. Then blue, all your blue in, and then none, or what's called a UV IR filter, and it allows all your colour photons in. And then you combine them into remember I said every digital photo was made up of a red, green and blue channel, so you literally combine them, red, green, blue together, and you get your colour photo. Your luminance one there, it lets all the photons in, so usually you would do a lot of exposure times with your luminance filter, which allows all them in, and then 1 or 2 hours each on the other 3. And that gives colour to the data, so you'd have all this data and those colour.
Would you get much better photographs with the monochrome using the 3? I know it takes longer, but would it turn out?
Yeah, so this is the Rosette Nebula. It hangs around Orion, the left of Orion. And this is a 2-hour integration with an OSC. This is 2-hour integration with mono RGB filters. You can get the same result, it just means you have to go longer with your one shot. So like you just might have to, is it 3 times faster monos or something like that?
Yeah, something like that. I shot was out last winter. I spent about 12 hours on it, and I've seen people do 3-4 hours and getting the same results using mono camera.
And if you're in a dark site, you're nearly better off going with your one-shot colour camera. If you're out in Kerry, and you've got Portal 1, Portal 2 skies, one-shot colour camera, go with that. I would say I wouldn't, you could go mono, but for the ease of it, I nearly go with that because you've got such good signal coming down from the sky. No light pollution, nothing interfering.
Well, I keep up the detail.
Yeah.
Concentrate on taking one set of good stack of luminance.
Yeah, exactly, exactly. And do the colour when you get home. Yeah. this is a very bare slide, sorry. I think I wasn't able to imagine back to it. But, so your advantages for your one-shot colour camera, simpler process flow, probably cheaper as well, rigs. Mono, you get more data. Disadvantages for one-shot colour, less data. And then for the mono, again, complicated, but it's just like. So narrowband then, what's narrowband? So that red, green and blue spectrum, that's your visible light spectrum, right? The red, green and blue kind of versus a lot of that. So your narrowband filter actually is targeting gases as opposed to colour. So the three most common gases out in space is, well, the most common is hydrogen, it's like 95–99% or something like that. Then you've sulfur, or then you've oxygen, and then you've sulfur. And they emit at a very specific wavelength. So what they did is they designed filters that are, only allow light in at that wavelength, that very, very narrow wavelength, right? So 3 nanometers, 6 nanometers. So you'll take your hydrogen alpha filter, you'll point it at your target, and you'll get, honestly, the signal of a hydrogen alpha filter, it's unbelievable. It's just jaw-dropping. You point it at a target and you have it for a minute, and you really have an image as good as a one-shot colour camera. Like it's unbelievable. And then, so you do a couple of hours with your hydrogen, you swap over to one or the other two, and when you're finished, you combine them, and what you end up doing is you assign your sulfur to red, for example, your hydrogen to green, and your oxygen to blue in your processing, and that's called the SHO palette, or what it's also known as the Hubble palette, and that is what all those pictures that Hubble released over the years are all done in that kind of classic SHO Hubble palette, exact same way. So here you can see your one-shot colour camera, your monochrome, RGB filter, and then your narrowband. The advantage to narrowband, again, like I said, is I image from the city, and because you're really just looking at that tiny wavelength or window of wavelength, you're cutting out all that noise, all that light pollution. The moon is just a killer when it comes to astrophotography. So I've imaged now like the full moon up in full swing, like it doesn't stop you anymore, and you still come out with really good images. I'll fly quickly through this. Some of the problems you'd have with imaging, vignetting, very common with faster scopes or lenses, so that's where the light is kind of coming in, more concentrated in the middle as opposed to the outside your glass, and so you get this kind of light gradient across it. Dust in the image stream, you can't see it here. There's these big, horrible dark rings. So if there's a piece of dust close enough to your sensor or on your filter, it's going to come up in your image. Amp glow, which is associated with those, and you'll see it in DSLRs as noise as well. So how do you do that? At the end of every session, unfortunately, you have to take calibration frames. So flat frames, basically, you point your telescope at something bright, a bright light, not as bright as that, but something like that, right? And you take very fast pictures, and it shows up all those dust motes that you have in your frames. And when you're processing, when you're snapping actually your images, it'll remove that image from your image, so you don't get those dusty things coming out in your final image. Dark flats, you're exposing the same amount of times your flat frames, but with the lid on in dark, and just so that you can subtract the noise that you're generating from your camera and all that from the flat frames. Dark frames then remove hot pixels and amp glow. So if you're exposing for 3 minutes for each image, you'll expose in darkness for 3 minutes in the same settings. So that noise that's generated by just the camera itself, you can subtract that from your images.
you do it at the same temperature, so why do you do it the same way? It's not like you go home and go, oh, I forgot to take my dark frames. You have to really take the dark frames with the camera in the same state that you're taking your subs.
That's the one advantage of dedicated cameras, because you can control the temperature. You can actually do your dark frames later if you want, because you can set the temperature and you set it at night. So yeah, every single rig comes with pluses and cons. Everything. So this would be kind of just a, you know, you have your netting and your dust modes and all that before, and that would be your image after, using your calibration frames. And that's the presentation really. As I said, we're part of a Facebook group called Astrophotography. We're building a website at the moment as well. We had our first workshop during a couple of months ago. We all met up, astrophotographers, for the first time, you know, ever, and it was really nice. So do join us if you want. And any questions?
Very good.